We live in an exciting technology era, the quantum age. We are ADR or quantum pioneers, just like Max Planck, Albert Einstein, Paul Dirac, Arthur Schawlow, Charles Townes, and Richard Feynman. These guys introduced quantum electrodynamics to the world, or QED. Now, QED mathematically describes all particle and wave phenomena involving the interaction of electrically charged particles, such as photons and electrons. This represents the quantum counterpart of classical electrodynamics, giving a complete account of the interaction of light with matter. All of these eminent scientists were not only recipients of Nobel Prizes for physics, but they also shared the fundamental understanding of the behavior of electromagnetic light energy, both visible and invisible, going on and through materials. Feynman, for example, demonstrated how light photons interacted with material electrons and showed how their direction of travel and penetration through the media were affected. Charles Townes figured out how to classify materials based on microwave maser spectroscopy. Now, when I started to apply similar theories to how radio waves and microwaves interact with materials, I found that it was possible to increase the depth of penetration of radio waves and microwaves into the materials, and also using group wave combinations to obtain an identification of the material through which the lased ADR beam was being transmitted. ADROC's science is based on, firstly, the detection of radio waves and microwaves reflected by the boundaries or interfaces between different materials. Secondly, it is concerned with the analysis of these echoes to deduce information about the type and nature of material causing the reflection. Different materials are characterized by their dielectric constant. This defines the specific way they interact with electromagnetic radiation, such as radio waves and microwaves. ADROC's ADR scanner generates what we term circularly polarized progressive standing waves. Now, these impulse beams of energy are like tidal waves. They are focused, they are coherent, and they are repetitively sent into the ground from the ADR scanner's transmission control unit. These beams are using low power, and they can travel to very great depths through the Earth's surface and return back to the ground surface to our receivers. We laboriously, mathematically track each and every beam transmitted down through the ground and then back up through each of the layers to our receivers at ground level.